It's my great pleasure to introduce Professor Ken Caldeira, who is a climate scientist at the Carnegie Institute for Science at Stanford University. And he's going to give us a brief overview and reporting on the very recent National Academy's report on geoengineering and present some of his group's most recent results on geoengineering. Ken.
Thank you. So I have to say I was panicking a little bit about this talk because usually I'm giving talks in front of people who don't know anything, so I can get away with some general overview talk. And but luckily I did some talks earlier today, and earlier this week, and people suggested that it would be of interest to hear about this new U.S. National Academy report that came out. And I'll focus on the solar geoengineering side, and then just give some update on some of our recent research results. And so do I use this to, okay, there we go. So maybe, I forget how many months ago, but a couple of months ago, I guess in February it was, these two reports were released by the National Research Council, which I think incorporates the National Academy of Sciences and the National Academy of Engineering. And the first thing to notice is that there were two separate reports issued, and that's because the panel felt that there's such differences between carbon dioxide removal and solar geoengineering that it didn't really make sense to put them both together in the same context where you were not also including the broad array of things designed to reduce climate risk. And for example, for carbon dioxide removal, considers biomass energy with carbon capture and storage. And it's felt that it doesn't make that much sense to talk about that in the context where you're not talking about biomass energy. Without carbon capture and storage, you're not talking about carbon capture and storage from fossil fuels, but you are going to talk about it with putting aerosols in the stratosphere. So I have to say that I wasn't happy to see these sort of both branded with climate intervention, because for the foreseeable next decades, while we're putting greenhouse gases into the atmosphere, any carbon dioxide removal is only going to reduce net anthropogenic emissions. And so I see it as a way to reduce intervention in the climate system. And so to characterize a way to reduce intervention in the climate system as climate intervention, I thought was not helpful. Okay, but I think it's much more clear to say that solar geoengineering, or albedo modification as it's called in this report, or SRM as it's called in this meeting, is pretty clearly intervening in the climate system. So the report did not attempt to be comprehensive. On the carbon dioxide removal side, it focused on two main avenues, and one of them being biomass energy with carbon capture and storage, and the other being direct air capture from the atmosphere with subsequent storage. And I think one of the novel things of this report relative to, say, the 2009 UK Royal Society report is there's a greater emphasis, I think, on various accelerated weathering and ocean alkalization approaches than previous reports. But still, it's not featured as much as these two primary pathways. On the solar geoengineering side, the same sort of triage was put forward, in which the report basically focused on two proposals emphasizing stratospheric aerosols, and then secondarily, I would say, marine cloud brightening, and basically has felt that the sort of outer space kind of things weren't particularly feasible, and the land or ocean-based albedo change were either limited in their potential scope, or at least limited in the available literature. So I'm basically at this point just going to go through the primary findings and sort of explain some of the nuances which seem to have been missed in a lot of the press accounts. I guess I don't need to go through this whole list in this group, and this, I would call this the sort of the more promising and less problematic carbon dioxide removals, and the more promising, and if it's sensible, less problematic albedo modification proposals. But basically these are carbon dioxide removal, really addresses the physical causes of climate change, meaning increased greenhouse gases, but it's slow. There are no big multipliers with chemistry. Each CO2 molecule that gets put in the atmosphere, you have to do something to get that molecule out. There's no big multipliers. Whereas with physics, there are the big multipliers. You can have one particle in the stratosphere, scattering billions of photons. And so, these are sort of symptomatic relief, symptomatic relief, but are fast and cheap and imperfect. And these are slow and resource intensive for the most part. So, the first conclusion was basically motherhood and apple pie, saying that, look, focus on mitigation of greenhouse gas emissions and adaptation, and these kind of solar geoengineering or even carbon dioxide removal should not be the primary focus of efforts. The other one, which is not the subject of this meeting, is that basically that there should be a research program in carbon dioxide removal. And I mean, given the state of funding in the United States, it's a question of how much additional funding there would be, but the idea that there would be some expansion of scope of existing carbon capture and storage programs might be possible. So the third recommendation is that albedo modification at scale sufficient to alter climate should not be deployed at this time. So there's two things here. One is the nomenclature. This report uses the nomenclature of albedo modification. I don't really want to argue the pros and cons of that, but that's what it did. And I guess some of the controversy was that at this time what doesn't preclude the idea that there could be some time in the future where it might be sensible to deploy it, but that now to our panel didn't seem sensible to deploy it at this time. That doesn't seem like a controversial thing. Some people wanted stronger. Yes, so one of the things that was interesting is that the committee recommends an albedo modification research be developed and implemented. That is, the research program should be implemented, not the modification itself. And so, so basically the panel came out in favor of research program or programs in both of these areas. And in terms of what kind of research should be emphasized, the idea was that there's a lot of climate science that is also relevant to solar geoengineering research, and that the research that you would want to emphasize tends to be research that would contribute to basic climate science understanding, but is also useful for understanding possible consequences of solar geoengineering. And so the idea is that if somebody's planning an experiment and it yields useful knowledge about the climate system, that it being relevant to understanding about solar geoengineering should be looked at as a positive element, a positive feature of that research, and shouldn't be seen as something that would work against wanting to do that research. And one of the sort of more interesting and more widely reported conclusions or recommendations of this report is saying that small-scale experiments might be helpful. And this has been widely reported as the National Academy coming out in favor of small-scale experimentation. And I would just say that the position is somewhat more nuanced than that, because the small-scale experiments, the panel agreed that small-scale experiments would likely be helpful from a scientific perspective, but recognized that there could be political or social feedbacks that would make such experimentation counterproductive in the long run. And so the panel recognized the scientific utility of doing experiments, but didn't go so far as to say if you consider the broader range of concerns that such scientific experiments would be recommended at this time. Yeah, so one of the things that became apparent is that we really don't understand Earth's radiation budget very well. If you try to diagnose what the shortwave and longwave fluxes are at the top of atmosphere based on observational capabilities, there's really not that good of a set of satellites up there, and the expected lifetime of these satellites is not encouraging for long-term monitoring. And so basically, that there's a need to improve our monitoring of ongoing changes in the climate system. And again, this is another example of the kind of monitoring, just like the research is good for both basic climate science and to understand this problem, this kind of monitoring is important to understand both the ongoing changes, the inadvertent influences on the climate system, as well as monitoring any potential intentional interference in the climate system. So the governance side, I know this isn't a meeting about governance, but and our panel wasn't heavily constituted with people who were experts in governance. And so basically the panel more or less punted on this, but put a few pointers. And so basically the panel only asked for the initiation of a serious deliberative process to examine what types of governance would be needed beyond those that already exist for albedo modification research, and then try also to discuss what types of research would require this governance. And so, so basically our panel didn't feel that we were in a position to make these determinations, and that it needed to be a more inclusive process with a broader set of stakeholders and people who have thought more about it than we have. But there was some sub-bullets with this that I'd like to go through, even though this is a science meeting, not a governance meeting, that basically that this process to discuss what sort of governance would be needed needs to be transparent, have input from a broad set of stakeholders. Yeah, so this, there's a lot of legalistic type language in this, so it should consider clear and quantitative guidelines. Some people think that there should be some allowed zone that you could define some amount of mass or amount of radiative forcing or something beyond which, or beneath which you wouldn't need to have additional regulation. And let's just say a position where you don't think this is good is also consistent with this statement, because it's just saying you should consider this. It doesn't say that that's really what you should do. And I myself think you could argue that if you want to put materials in the stratosphere for any purpose, there should be some governance system for that. And then, if there's some tiny little amount that won't have any effect, maybe there's some kind of pro forma approval. But it's not obvious that you need to define this kind of thing before setting forth some sort of system. So anyway, yeah, that also in terms of the solar geoengineering research, the research should focus on things that involve putting things in the atmosphere, meaning either into the stratosphere or the marine boundary layer primarily, and that, that there's not a clear need to focus on, say, surface albedo modification or other things like that as a focus of governance efforts. And then again, this is similar to that scale issue. Some people think that this question of de minimis, or is there some scale of experiment that would basically have a greatly reduced governance needs. Yeah, and the idea is also that if you have, with small scale experiments might need a relatively light level of governance, and that as experiments scale up, if they do scale up, that the level of governance would also need to scale up proportionately, and that, basically the idea that it might not be helpful to generate a huge sort of regulatory architecture to cover very tiny little activities. And then motherhood and apple pie, maximize benefits, minimize risks. Yeah, so I noticed this once read a lot more differently in the United States than outside of the United States. And so the concern of the panel is more that the United States wouldn't participate in a more international process, and that kind of just the Europeans and others would move ahead with thinking about how to institute governance while the United States basically sat out on the sidelines. And so this wasn't meant to imply some sort of unilateralism, but basically that the United States should be an active participant, might have been a better way to word it, in the development of best practices and norms for experiments. And so that's more or less the main conclusions of the report. And then in addition to these main conclusions, there's what I would consider more or less pretty, basically a big review paper that reviews the state of the science with respect to these different things. But this was the recommendations. And so, okay, so with that done, I'm just going to do like 2 or 3 minutes of motivation for solar geoengineering research, and then talk about some of our results that are only moderately relevant to this meeting. Yeah, and so one of the things that motivates me to work on this, besides just thinking it's interesting science, is this figure from Battisti and Naylor of 2009, looking for a business as usual scenario. What fraction of the summers are hotter than the hottest summer on record? And basically throughout the tropics, almost every summer by the end of this century, if current emission trends continue, will be hotter than the hottest summer yet on record. And often these extreme record heat summers have been associated with crop failures. And so it's not my expectation, but I think there's at least a possibility that by the end of this century, we could be seeing widespread crop failures throughout the tropics. Many of the crop models for this scenario project increased crop yields in the northern mid-latitudes, Russia, Canada, due to increased growing season length and increased CO2 fertilization. And so even the sort of dire situation where you see widespread crop failures throughout the tropics, there's likely to be enough food in the world for everybody to eat if you had equitable distribution. And so one of the changes in my perspective about this problem over the last few years, I used to think of a climate catastrophe being a purely physical thing, that there's a change in the climate system that produces some kind of crisis. And now I think that there's a really combined, maybe a climate driver coupled with an institutional failure to have equitable, to take care of people in need. And, and I think we've seen enough institutional failure. The whole effort to reduce greenhouse gas emissions, I think, can largely be characterized as institutional failure. And so the idea that there could be widespread crop failures and coupled with institutional failures leading to widespread famines is at least plausible. And so that if a national leader, say here China's pretty red in here, or that if hundreds of people, millions of their people were threatened with dying of a famine, and they thought that cooling the earth rapidly could help feed their people, there could be intense political pressure to deploy a solar geoengineering system. And so I think it's really important that we understand potential consequences of such deployment in case such intense political pressure ever develops. So this is the SRES scenarios, not the recent RCP scenarios. And I did that on purpose because the RCP 2.6 involves huge amounts of carbon dioxide removal, and that manages to keep more or less a steady temperature. But even the RCP 2.6 doesn't really cause atmospheric temperatures to start decreasing. And the point is that if we should be somewhere in here, and there happens to be that coupled institutional failure, coupled with climate change that causes widespread crop failures, that the prospect would be for the things to get worse in terms of the climate system, for the climate to continue changing. And so there's basically no way for emissions reductions to cause the temperatures to start decreasing this century. And so there's basically only one known way that political actors can cause temperatures to decrease this century, and that's solar geoengineering. There might be some, there might be some little bit of leverage with short-lived greenhouse gases and aerosols. And so, okay, so that's a basic point, that there's only one thing a politician can do to cause the Earth to cool on a time scale that's politically relevant to the politician, where the Earth starts cooling either within their term or at least within their political career. And this can be illustrated by this paper we had a few years ago with this, I'll just focus on the red line for now, that this red line shows a sort of business as usual scenario, and then in 2050, instantaneously all emissions are zeroed. And the result of zeroing emissions, the atmospheric CO2 concentration goes down, but basically temperatures remain constant for centuries. And so even zeroing all CO2 emissions does not cause the Earth to cool. It just prevents further warming. Basically, you can think of each increment, each CO2 emission is another increment of warming. And that if you really want to cause the Earth to cool, just stopping, even completely stopping emissions doesn't do the job. And so I think this idea that the tropics will be sort of what's now would be considered record heat almost every year, and that there's no other way to cool the Earth than these solar geoengineering things, I think gives at least the possibility that there could be intense political pressure to deploy these things. Let me just say something about social acceptability. I heard somebody talking about different particles that could be put in the sky to try to reflect sunlight, and somebody said, so there's that one of the forms might be some kind of carbon in the form of a diamond, but sort of I don't know what is 0.1 micron, little tiny things. And people think, okay, people will never put up with this. But if the American population put up with kidnapping and torture through the Extraordinary Rendition Program, with surveillance of all our telecommunication and our movement, and when it was announced post facto, most Americans were fine with it. And I think if a political leader announced, oh, we started putting diamonds in the sky to protect you, I think if they put up with kidnapping and torture, they'll likely put up with diamonds in the sky. So I think this idea that people are not going to accept these things is maybe overly optimistic. So this is just to say Mount Pinatubo evidence that the Earth can cool quickly. So within somebody's term in office, they'll start seeing a response. And so if people are dying and they ask the politicians do something, that something they can do to see a response within their term in office. Okay, I'm actually now going to talk in my last couple of minutes just about two things. I should probably leave time for questions and not talk about these, but I want to show something new. And we have two things that aren't really solar geoengineering, but they're still interesting. We have two papers coming out within the next couple of weeks, and one is this idea of mixing the whole ocean vertically to cool the Earth. I probably don't have time to go through these, but let me just jump through. So basically, we just mix the whole ocean down to 1 kilometer, sort of simulating the extreme ocean pipes kind of scenario. And let's look at the dashed line because it's sort of simpler to understand. That's just, this is the control simulation, global temperatures. And this is with the pipes. And so you get something like 12 or 13 degrees of cooling, or no, I'm sorry, 13 to 5, yeah, it's something like 8 degrees of cooling But then the Earth warms up, and by the end of, within a half century or so, a little over around a half century or so, the Earth ends up being warmer than it was before had you never done the ocean pipes. And it just sort of shows some of the, this is in a coupled ocean atmosphere climate model, CESM. And what happens is you cool the ocean surface relative to the land, and so then you cool the volume of air over the ocean relative to the air over the land. And so that means that you have, you increase the mass of air over the ocean, and so the pressure is higher over ocean than over land, and or at least the tendency towards that, and you tend to induce a sinking of dry air over the ocean and an updraft over the land. That sinking of dry air over the ocean tends to obliterate clouds over most of the ocean, and so instead of presenting clouds to the atmosphere, you present the dark ocean surface, you absorb more sunlight, and eventually the ocean warms up warmer than it would have been otherwise. And so this sort of, and we've done this at a few other things, but a sort of unexpected result in the models that on the century time scale, this sort of mixing the ocean, trying to mix heat into the deep ocean actually ends up being counterproductive, at least in the model. I won't go through carbon cycle. Interesting thing just for the people who are fans of Gregory plots, and I hope there's a few fans in the audience, that even though it's a really interesting thing, the effective radiative forcing from doing this is over 15 watts per square meter. And it's really interesting to have something where you just do something to the ocean interior and you end up with over 15 watts of effective radiative forcing. Because most things that produce effective radiative forcing, you're doing something directly to the atmosphere. And okay, let me just run that. And I'll just do one quick one and then I'll get off the stage. So the other one is this, that we also started looking at people, this is actually solar geoengineering, so this one's more relevant. That people have suggested that, methane might pour out of Siberia, and so can we do something to restore sea ice? And so what we did is we took, again, a coupled ocean atmosphere CESM, and we did a bunch of different treatments, of which I'll talk about 3 here. One was we took the ocean area north of 70 degrees and made it essentially white in an effort to regrow sea ice. And then we also did it where we just whitened the Arctic Ocean north of 80 degrees in the model to try to get sea ice to grow. And then to sort of check linearity, we did one from 80 to 70, and then you can see as the sum of the two things the same as the one bigger one. And so the basic results is this. This is the pre-industrial sea ice extent. This is 4 times CO2 sea ice extent, and these are the changes from these different treatments. And basically, you get something like half the sea ice to regrow. And if you do, so basically when you first do this, more or less for each square kilometer that you whiten, you get about a half a square kilometer of additional sea ice, but then later, once that sea ice grows, you don't have to alter albedo of as much area. And so you end up with a ratio of that for each square kilometer of sea ice that you need to maintain as sort of white, you get something like 3/4 of a square kilometer of sea ice. But it turns out, let me just jump to this one because I'm running out of time. That in terms of the permafrost area, this is supposed to be 100, is showing the permafrost at the 1 times CO2 state, the amount of permafrost left at the 4x times CO2 state. And that doing this is these 3 treatments I just spoke about. Doing it, you save a little, you help protect a little bit of more permafrost, but not very much. And basically at 4 times CO2, you have so much energy coming in outside of this albedo modified area that the influence of the Arctic sea ice restoration on the continental climate is rather weak. And that, so even this huge effort, which is going over millions and millions of square kilometers, that it really is very marginally effective at protecting permafrost, even though it's reasonably effective at restoring sea ice. So I think this idea that you're going to restore sea ice and that in itself is going to protect permafrost just doesn't seem to be right. And so I'll shut up now.
So we have time for a couple of questions for Professor Caldeira. Right at the back. Jim?
Yeah, I think you need to get some running shoes on if you're coming up here. I was interested about your maximum exceedance of the warmest day, warmest summer.
Batista-Naylor's maximum. That was not my work.
Okay. I think it's interesting. Why doesn't that show what you would traditionally think in terms of the snow ice albedo impact? Because global mean temperatures are always forecast to be much, much higher at the poles than, in terms of temperature change.
Yeah, it has to do with the amount of natural climate variability. So you think one of the things that determines the warmest day is at the poles, there's a lot of variability. And so over the last century, you've had some years that were very warm, whereas the tropical region tends to have much less temperature variability, and so it's really a signal-to-noise issue. While the amount of warming is higher at the poles, the signal-to-noise ratio is higher in the tropics.
Okay, so for the record, that was Jim Hayward from the University of Exeter. Peter's next. Okay, so Peter, then Andy.
Thank you for that excellent talk. Given the timescales involved, what do you think a reasonable timescale, if one is going to do research into solar radiation management, should be?
I don't know if the timescale is, maybe another way of rephrasing the question, if we assume that research is some kind of portfolio, maybe the question is, what is the sort of fraction of research dollars that should be put into solar geoengineering versus other activities? And, that I've written just as sort of a ballpark, and I'm not sure it's the right order of magnitude, but, if you think that, I suggested maybe it's sort of like let's say you'd have a clean energy R&D program, that I would think a solar geoengineering program might be sort of like 1% as big as that, or something like that. I don't know the exact numbers, but I definitely think it's small relative to, say, clean energy development research programs, and also should be a small fraction of general climate science.
We did a survey of about 200 chemical engineers around the world, and they came up with very similar figures, 1 to 2%, which I think would mean an increase of 2 or 3 orders of magnitude over the current expenditure.
I think that's right.
Okay.
Yeah. No?
I was going to go with Andy Jarvis next.
Can I just ask I mentioned diamonds, and I just want to see if there's somebody in the audience who would actually propose that, so that I'm not stealing somebody else's thunder there. Is that, did you say that, David, or no? Okay.
Yeah, I'll present some stuff on that tomorrow, but I have a question.
Okay. Well, I'm not the one.
Okay, I'm going to go Andy, then David, and then we're going to move on.
Well, I wanted to talk about the diamonds. So
okay, well then you should probably talk to David.
But I want to talk about the fact that you called the fact that people would not necessarily reject diamonds in the sky overly optimistic, and was that just a slip of the tongue? Or?
No, I mean that. I'm actually very much feeling that the Earth system is extremely complicated, and the more we interfere with it, the more likely we are to screw things up, and that I would much rather see us be working very much harder on emissions reduction. But I think, I gave my motivation here, that I think there's potential for really serious outcomes. It's not my expectation, but it's at one end of the probability distribution, and that we should be doing the research now so that if that outcome ever happens, that people have some more information.
So the term overly optimistic refers to your position and not necessarily the people that might reject it?
I only speak for myself. I do not speak for civil society.
Yeah.
Okay, final question. David, please.
It's relatively easy in a climate model to just make all the water in the Arctic more reflective. can you think of any remotely plausible way that you could actually float materials in the Arctic that would not be environmentally enormously destructive? And,
No.
and if the answer is no, then can you just say a little bit about whether you're letting that out in the paper?
Yeah, I would say this, that people have proposed doing this. I mean, one of the things that we do is we sort of make climate models do things they weren't designed to do and see what happens. And, I guess we present this more in a climate science-y context, and I don't think, I think we just say it's been proposed and we don't do an engineering evaluation. But there was that 1965 PCAS report saying spread plastic on the ocean, which sounds awful. And then there's this micro bubbles thing, which I think is probably, my sort of intuition is that it's infeasible, but I'm not an expert. And so I would guess that it's, if you look at the scales that we're doing here, it's, each million square kilometers is 1,000 by 1,000 square kilometers, and so you'd have to do like at least 10 of those blocks to have any effect. And then if you even see even if you could do it, the global mean temperature change is on the order of epsilon. And so, I think our conclusion was, let's look at the climate science, and if we show, our approach is look at the climate science. It says even if you could do it, it doesn't buy you very much. And so don't bother working on the technical means to do that. So I think you can work from both sides, but I think our conclusion was it's not a particularly good idea, and if it's also technically infeasible, that means it's even worse of an idea.
Okay, thank you very much, Ken, that's great.